June 2005, C1 question 10, and it is an curve equation question. Read on down, you can see we have equation of tangent and so on in it. Part A, 1 mark, so it shouldn't be too much work for 1 mark, and it's showing a P lies in C. So it's taking the coordinate 3, 0, and saying that whenever x is 3, y should be 0. So what we're doing is we're subbing that in to the top equation. So y equals a third 3 cubed minus 4 times 3 squared plus 8 times 3 plus 3. So y equals a third of 27 minus 4 times 9 plus 24 plus 3, which is 9 minus 36 plus 24 plus 3, which does come out as naught. So we've shown that P lies on C because whenever x is 3, y comes out as naught. Part B, and mentions equation of the tangent. So at some stage we should have to use this equation, so put it down and see what we have and what we need to find out. And it's the equation of tangent at P. So P is still 3 naught. So x1 is 3 and y1 is naught. So it's m we have to find. Now when you're looking for m, you're checking you're going to be using your formula for whenever you have 2 points, or does it mention parallel or perpendicular, or is it differentiation? And because we have a curve, and this question doesn't give us, only gives 1 point, so it's definitely not this one, so therefore differentiation. So we take our y equals a third x cubed minus the 4x squared plus the 8x plus 3, and then dy by dx is going to be 3 times a third x squared, so decrease the power, multiply and decrease, multiply by the whole power and decrease the power, minus then 2 times the 4x plus 8, the x drops off and we don't have anything for the 3, so it comes in x squared minus 8x plus 8. Now that's the overall equation for this curve to get a gradient at any point, but we know that the point is 3 naught, so x is 3, so sub in then 3 squared minus 8 times 3 plus 8, which is going to be 9 minus 24 plus 8, which comes out as minus 7. So now for our equation, y minus y1 equals m x minus x1, we know y1 is naught, we know that x1 is 3, and now we know that m is minus 7. So y equals minus 7x plus 21, and that's in the form that they had asked for. So moving on to part C. It tells us we have an R point that lies in C. So an R point Q lies in C, so we're still going to be using the top equation. The tangent to C is parallel to tangent, so there's the key word. So because the tangent at Q is parallel, we know that the gradients are equal. And we know that the gradient at P is minus 7. So therefore the gradient at Q is also minus 7. And the overall equation, as we said earlier, for the gradient is x Well, the y by the x equals x squared minus 8x plus 8 from part B. So I'm going to set that equal to minus 7. So that's what the gradient comes out as. And now it's just our quadratic, and to solve a quadratic we bring it over and let it equal 0. So you have x squared minus 8x plus 15 equals 0. What gives multiplies to give 15? And we'll add subtract to give minus 8. So x minus 5 and x minus 3. So x has to be 5 or x has to be 3. Now, this confirms we're doing it the right way because we've already got the x equals 3. We're told there was a point on the curve that had a tangent where x was 3 equal to minus 7 as a gradient. So x equals 5. We don't need to use the 3 again. So using 5, we need a y value, and we are summing it back into the top equation. So y equals 1/3 times 5 cubed minus 4 times 5 squared plus 8 times 5 plus 3. And of course, no calculators. It becomes just a bit awkward because of the fractions. We have 125 over 3 minus 100. 4 times your 5 squared plus 8 times 5, which is 40, plus 3. So y equals 125, group the whole numbers together, it's going to be minus 57. So we get this out of 3, so y equals minus 125 over 3 minus 127 over 3. And now take away your fractions. Y equals minus 46 over 3 or minus 15 1/3. So we've got then our coordinates of Q. If you want to put it down again at the bottom for examiners to see quickly, it's going to be 5 and minus 15 thirds.